Students, welcome to section 4.7, which is optimization. So what's happening is we want to maximize or minimize something. That's called a Q, subject to a constraint. So the first thing you do is you read the problem, of course. So in this section, they're all going to be word problems. Read the problem again. Draw a diagram. For many of these problems, diagram is going to be very helpful. Introduce variables and use symbols that will help remind you of what they represent. Don't always necessarily use X. Express Q, which is what you're trying to maximize or minimize, subject to a constraint. Express Q in terms of the variables you just introduced. And then when you use the given information, that's implying that it's going to involve the constraint. And what you have to do is, and this is very important, express Q in terms of only one variable. And then use the methods learned previously. And primarily that's going to be the closed interval method. Because what we're going to do is we're going to maximize or minimize something on a given interval. So let's do a problem. So here's the problem statement. We're asked to find the dimensions of a rectangle, or the rectangle of maximum area that can be inscribed in a circle of radius r is equal to 4. So what are we trying to do here? Maximum area, we're trying to maximize the area. So area happens to be our Q in this case, doesn't it? Inscribed in a circle, that would be our constraint. Okay, so let's see. What is the area of a rectangle? The area of a rectangle is length times width. Okay. Now, what does it mean to inscribe a rectangle in a circle? It means that each of these four corners is on the circle, okay, and none of the rectangle lies outside of the circle, okay, and let's see here. That would be not a radius; it would be the diameter. So this would have to be 2r. So we're getting somewhere. Remember, area is length times width. That's our Q, right? Now, what I have to somehow do is get this in terms of, get the area, which we're trying to maximize, in terms of only one variable. So the constraint, the constraint is that our rectangle is being inscribed in a circle, but I need an equation. Okay, so if you look at this picture here, what I actually have here is a right triangle. So can we say that L squared plus W squared equals 2r, the quantity squared? Can we say that? Now, r we said is 4, right? So 2 times 4 is 8. 8 squared is 64. So what I can do is I can solve this equation for L. Isn't L going to be the square root of 64 minus W squared? Isn't that what it's going to be? So what that means is that the area, and this is very important, this is where we have our quantity in terms of only one variable. Remember, area of a rectangle is length times width. So area is going to be, again, length times width. So we have W times the length, which is 64 minus W squared, right? Now we do have an interval here, right? It makes sense that W be between 0 and 8. So we're going to use the closed interval method. I mean, obviously W can't be negative, and W can't be greater than 8, because we have a negative number inside the square root, right? So what we have to do now is find the values of W that will give us a maximum.